Generic classes. There may be multiple classes which are mostly identical, differing only their data types. So let's see one example over here to understand the advantage of generic classes. Okay, so the first class triple int has three items, integer type of items, and this is the parameterized constructor for initializing the items. And now print function to print all the item values, and one mean item function to find out the minimum value in between these three integer types. Then these are three short element types, short integer, and we are basically doing the same thing, having a parameterized constructor like the integer class here, print all function, and the mean item function. So both the classes doing mostly the same things with only managing the different data types. In one we have integer type, in another we have short type of data. So is it efficient to write the same code again and again repeatedly? So like you have seen in generic methods, we do use a different context of writing a program that is called generic classes. So here the generic classes gives us an idea for writing and maintaining the repetitive or redundant classes which only differ by their data type, and it gives us the capability for reducing the um, time consumingness of a program or a class to be written twice for handling different data types, and also sometimes they can be error prone. So how to have a generic class then? Let's see one program over here. What I'm trying to tell you, like in the example we have seen, we had one parameterized constructor, print all function, and mean item function to find out the minimum item. Now what we can do, we can create one generic class which will extend the comparable interface, and basically creating of one generic class type, the type, and any items or elements that we will create in that will belong to the type or the generic type or global type. So what will happen then if we try to invoke all the member variables or all the member functions of this triple item 8 class here? So in the driver class in triple item manager 9, here we can do one thing. We can invoke the methods in this class using or creating the two different types of um, objects here. So first, let's say you want to find out the minimum value for the integer type. So there you can do one thing. You can create one object try ints which belong to the triple item 8 class, and that object will basically handle the integer type of data. So this statement, what it will do, it will create the object try int along with invoking the parameterized constructor here with three arguments I1, I2, I3, having the values as these three values. Now the parameterized constructor have been invoked. Now if you want to find out the mean value in between those three values here, then this try ends dot mean item. This object will invoke the mean item function, um, the same function, but here invoking the values of these three values that we have here and initialize them with the parameterized constructor. The same thing we can do for the shorts also, sort values. So create an object with initializing the values as 99, 55 and 66. Typecasting those values to the short type to handle those values. This total statement or instruction will invoke the parameterized constructor with initializing all the data values of the short item 1, item 2, item 3, and then through this mean item function it will invoke the same mean item function, but here passing or having these three values initialized through the parameterized constructor. That's what will happen here. So let's run the program and see what output we are having. So for first three values, the mean item will be invoked and mean item will return 5555 through this mean item function, returning the mean value here at last. Now for try shorts, these three values, the mean item will be invoked for try shorts dot mean item here in the statement and the minimum value will be returned as 55. So this is all about generic classes.